Hello my dear friends, in this video I'm going to explain you about how to draw the shear force and bending moment diagram for a simply supported beam which is carrying multiple loads, a UDL and 2-point loads as shown in the figure. Right. So for this thing, you know very well that first we need to calculate the support reactions. Right. So for that thing, what I'm going to do here is I'll take reaction RA at point A and let us take reaction RB at point B. Now, the first thing we need to do is we have to consider the entire system in the state of equilibrium and apply the conditions of equilibrium. The first condition of equilibrium is sigma fx equal to 0, as there are no other forces acting in the horizontal direction. That equation is ruled out. Now let us go with the second condition of equilibrium, that is sigma forces acting in the y direction is equal to 0. As we can see, reaction RA and RB both are acting in the upward direction. I'll take it plus RA plus RB. Next, 30 kilonewton, 20 kilonewton both are acting downwards along with 10 kilonewton. So it is equated to 30 plus 20 plus 10 multiplied by 4. This is UDL. So reaction RA plus reaction RB, which is equal to 90 kilonewton. I'll call this one as the first equation. Let us call that one as first equation. Next, I would like to take moment at point A. So sigma moment taken at point A is equal to 0. I'll generate the equation. So RB multiplied by 8. So it is creating an anti-clockwise rotational effect, should be taken as positive. So plus RB multiplied by 8 minus this 10 kilonewton is located exactly at distance of 2 plus half of 4. That means 6 meters. Minus 10 multiplied by 4 is the load, multiplied by 6 is the perpendicular distance. Next, we have 20 kilonewton. It is rotating in the clockwise direction, should be taken as negative. Minus 20 multiplied by 4 is the distance. Minus 30 multiplied by 2 is the perpendicular distance. It is equal to 0. So finally, we will get reaction RB, which is equal to 380 divided by 8, which is equal to 47.5 kilonewtons. So reaction RB, it is equal to 47.5 kilonewton. So substitute 47.5 in equation number 1, we get reaction RA, which is equal to 42.5 kilonewton. So we got reaction RA, which is equal to 42.5 kilonewton. So reaction RB is 47.5, reaction RA is 42.5 kilonewtons. Okay, now to draw the shear force and bending moment, right, the first thing what we need to do is I'll take a section. Let us take a section capital X and X. In between B and D, it is located exactly a distance of X from capital B. It is located at a distance of X from capital B. Now shear force at any section X and X, right, it will be equal to, as this force is acting in the upward direction, it has to be taken negative. UDL should be taken as positive. The shear force, so first I'll take UDL, 10 kilonewton acting over span of X. This is positive, minus 47.5, minus 47.5. Now shear force at a distance of X is equal to 0. That means shear force at point B, it is equal to 10 times 0 is 0. So we get minus 47.5 kilonewtons. We got minus 47.5 kilonewton. So I'm going to mark minus 47.5 directly over here. So this is point B. At point B, we got the shear force as minus 47.5. I am marking 47.5 over here. Right, so this is the point. The next thing is, let us calculate shear force at X is equal to 4 meter. That means shear force at point D. Now you have to remember one thing. At point D, exactly at point D, I am calculating shear force in between B and D. I am not considering 20 kilonewton here. That will be considered when I am taking a section in between C and D. So shear force at point D will be equal to, we have to substitute X is equal to 4 here. So plus 10 multiplied by 4 minus 47.5. Obviously this will be equal to 10 force is 40. So you'll get approximately 7.5. So minus 7.5. Minus 7.5 kilonewton. So I'm marking minus 7.5 kilonewton here at point D. So this is minus 7.5 kilonewton. And the variation, right, x to the power 1, we have x to the power 1 here, so variation will be linear. So it will be linearly varying here. Right. Next, let us calculate the bending moment in between the section B and D. So up to here, shear force is completed. bending moment at any section x and x, it will be equal to, so 47.5, the support reaction is creating a positive moment, so this will be 47.5 multiplied by x, and UDL will be pushing the beam in the downward direction, so it will be negative, minus 10 kilonewton acting over a span of x multiplied by x by 2. So this will be plus 47.5 into x minus 10x squared divided by 2. So bending moment at any distance x is equal to 0, it will be equal to 0. That means bending moment at point B, it is equal to 0. Now let us calculate bending moment at a distance of x is equal to 4 meters. That means bending moment at point D. So it is plus 47.5 multiplied by 4 minus 10 times 4 square divided by 2. 10 times 4 square divided by 2. Now obviously you'll get this value as 110 kilonewton meter. So I got bending moment at point D, which is equal to 110 kilonewton meter. So I'll do one thing, I'll directly mark the points over here, right? So I'm drawing the baseline. So at point B, I got the bending moment as 0, and exactly at point D, the bending moment I have obtained here, right? It is 110, right? It is positive 110. So I'm marking 110 over here, and the variation in between these two things will be parabolic, as it is a square. So I'm simply drawing a curve which is a parabola, and you can mark 110 in the middle also. Right. Next, let us consider a section in between C and D. I'm taking a section in between C and D, as you can see here. Let us call this one as section 2 and 2. This section is also located exactly at distance of x. Now shear force at any section 2 and 2. Shear force at any section 2 and 2. Right? It will be equal to simply algebraic sum of all the forces acting towards left or right side of the section. I am considering right side of the section, so it will be minus 47.5 plus 10 multiplied by 4 meter plus 20 kilonewton. So obviously I can write directly this thing, minus 47.5 plus 10 into 4 plus 20, right? It will be equal to 12.5 kilonewton. So I got this thing as a positive value, which is 12.5. So shear force at point D, right, which is equal to 12.5 kilonewton. 12.5 kilonewton. See, earlier for point D, we got the value as 7.5 kilonewton. We have marked here, right? It is negative. Now here we got 12.5 is positive. So I'm marking 12.5. This is 12.5, which is above the point D. Just join these two lines. Next, let us calculate shear force at point C. That means shear force at a distance of x is equal to, from point B, it is equal to 6 meters. So as there are no other forces in between C and D, it will be same again, 12.5 kilonewton. So up to point C, right? So here we have point C, right? It will be 12.5 only. So this will be 12.5 kilonewton. Next, bending moment. Let us develop bending moment at any section 2 and 2. So bending moment at any section 2 and 2. So the same thing again, reaction RB will be making a positive bending moment. So this will be 47.5 multiplied by x minus 10 kilonewton is the UDL multiplied by 4 is the distance on which it is acting multiplied by, at what distance it will be acting, x minus 2. So this will be x minus 2. Why x minus 2? UDL will be acting over a span of 4 meters, but it will be concentrated exactly in the half of the distance. That means this 2 meter is gone. The remaining distance will be x minus 2. 10 into x minus 2. And next we have one more force here, 20 kilonewton minus 20 multiplied by x minus 4. This is x minus 4. Now this 20 kilonewton is located exactly at distance of x minus 4 from point B. So I'm just regenerating the equation again. So this is plus 47.5 times x minus 10 multiplied by 4 is 40 times x minus 2 minus 20 times x minus 4. Okay. Now let us calculate bending moment at point D. Already I have calculated bending moment at point D, right? I got it as 110 kilonewton. Now let us check the same thing again. Bending moment at point D, that means bending moment at a distance of x is equal to 4 meters. So I get plus 47.5 multiplied by 4 minus 40 into 4 minus 2 is 2, minus 20 multiplied by 4 minus 4 is 0. So obviously you'll get 80 minus 47.5 into 4. The value here I get is 110 kilonewton meter. I got the same value, right? So I'm marking the same value here. Now for the same bending moment equation, let us go with one more distance, right? Bending moment at a distance of x is equal to 6 meters. That means bending moment at point C. Now in place of x I am substituting 6 here. That is 47.5 multiplied by 6 minus 40 multiplied by 4 minus 20 multiplied by 2. Minus 20 multiplied by 2. So I got a bending moment at point C, which is equal to 70 kilonewton meter. So this is a positive value. I'm marking 70 over here. This is 70. Right. Now I got two values over here. The next thing is, let us go with a section in between A and C. I'm going with a section in between A and C. Section number 3 and 3. Now this section again, it is located exactly at a distance of x. Let us take this one as x again. Now this section, either you can go with right side of section or left side of section. Okay, for my convenience, just I would like to do one thing. So I'm taking the section 3 and 3, which is located exactly distance of x from point A. From point A, I'll calculate. Now shear force, let us do it here, right? Shear force at any section 3 and 3, right? It will be equal to, towards left side of the section, we have only one force acting in the upward direction, should be taken as positive, plus reaction area, that is plus 42.5 kilonewton. Okay, that's it, got it. At point A, it is 42.5. I'm marking 42.5 here, and there are no other force in between these two things. That 42.5 will go up to point C and simply join a line over there. So that is it. This is 42.5. So everything is positive here. This one is negative. Same thing again. So no need to go with bending moment at point A. Obviously, bending moment at point A will be equal to 0. Why 0? Because it is a simply supported beam, and exactly at point A, as it is a support, a hinged support, this will be equal to 0. Bending moment at point A will be equal to 0. Simply draw a straight line in between these two things. Or else you can also generate an equation, and you can just get an equation for these things, and you can generate an equation and get the values. So I got this one as 0, right? So this is the bending moment diagram. Everything is positive. So that's it. Thank you.